Hassler here. All right, so I'm going to do a short video on finding initial values, our particular solutions, and then at the bottom you have a practice problem using the extreme value theorem. Okay, so you remember when we were doing antiderivatives and there were no limits, no upper and lower limit, and so we had a plus c at the end. That's called a general antiderivative or a general solution. But what happens if I have a known point on that particular function? I could use that known point to find the actual c value, and that means that we're finding a particular solution. And so that's what we're going to do today. So review of finding antiderivatives, one extra step today of finding the plus c. So I'm going to do one of these with you. Your job will then be to finish this page. All right. So it says to find a particular solution, and finding a particular solution means that I'm going to use this point, this initial value or initial condition, a point on the f function, in order to fill out what that c is. Okay. All right. So you can see that I'm given. You can see that I am given dy dx, or the derivative. That's the same as saying y prime. And my job is to find f, or y. And so that means that I would have to integrate 4x to the 7th, which means I'm going to tag a dx at the end. Notice there are no limits on this. I'm not evaluating on some particular interval. And so when I go to find this antiderivative, I'm going to add 1. So I get x to the 8th. And divide by that new exponent. And so that gives me 1/2. And then a plus c. And so what we technically found is the general solution. This would be called the general solution because it has this plus c. So what we really found is that f of x is equal to 1/2 x to the 8th plus c. Now I want to know the particular solution, and that means a specific solution. And I'm going to use this point on my f function or my y function in order to figure out what c should be. Now notice that green. Notice that this says y of 1 equals 3, and what that really means is that I have the ordered pair 1, 3 on my curve. And so that means I'm going to replace the y, or the f of x, with 3. I'm going to replace the x, or the x, with 1. And then my job is to isolate c. And so 1 to the 8th is 1, times half is half. I really have 3 equals half plus c. And if I subtract half from both sides, I get c equals 2.5. But I'm not done yet. Okay, I am not done yet. What I need to do next is I need to then actually write. It says find the particular solution for, I should get a different color, sorry. Find the particular solution for f of x. What that means is my final answer is going to look like this. F of x equals the 1/2 x to the 8th plus 2.5. This is my final answer because this is the specific or particular solution. Okay, so general solution would be the plus c, the function with the plus c. A particular or specific solution is that same function. This is that same function, but now I have a known value for c because the 0.13 is on this function. Okay, so again, your job is to do the rest of this page. Take a look at 4. You're given the second derivative. You know information about the first derivative, and then you got to go down and get the original function. So let's see what you can do with that. And this last problem here is taken off a past AP test, and it's just to continue practicing that extreme value theorem. You are asked to find the absolute maximum value, and I just want to make sure we get some practice with that. If you have questions, let me know.